Hi everyone, I hope you're okay and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the sixth question from the preliminary exam which was written in the year of 2024 in the province of Eastern Cape. Please do expect a total number of 12 videos since the question paper had 12 questions in total. And that simply means each and every question will have its own video, and please guys do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your preliminary exam and most importantly your final examination. So please guys do share the video to your peers so that they may have the same edge as you, and please guys do help us grow the channel by just subscribing. Okay, we are told that the diagram below shows the graph of f of x and g of x, né? And then we are also told that the domain for the two graphs is x is greater than 0. Okay, and then we're also told that the point P is the point of intersection of the two graphs, f and g. Firstly, they want us to determine the values of C and D. Okay, let's first find the value of D, now, because it's easy. I know that g of x is equal to d multiplied by x squared. Together, I can simply substitute an extra point that I have there for me to find the value of d. So I know that y is half, and the corresponding x value is also half as well. So this will just be equal to 1 over 2 is equal to d multiplied by 1 over 4. How can I remove these fractions? By multiplying both sides by the LCD, or basically let's just cross multiply just to make things easy. Let's just cross multiply. You'll end up having 4 is equal to 2d, and then divide both sides by 2, d is equal to 2. So that means g of x is basically equal to 2x squared. Okay, now let's go and find the value of c. We are told that the log f of x rather is equal to the log of is equal to negative log x base c. Are you together? This thing can be rewritten as log of 1 over c, rather of the log of x base 1 over c. Né? If I want to remove this this 1 over c, I just need to put a negative over there. All together, and hence I'll have that that expression. So these two things, guys, it's just one and the same thing. Né? Okay, now let's substitute an extra point over there so that you can find the value of c. I know that y is equal to 1 over 2 if and only if the value of x is also 1 over 2. How can I remove the logarithm? By making this guy the base on the left hand side. So I'll simply have 1 over c, and this over here will become an exponent to the power half. This is just equal to 1 over 2. Now the logarithm has been removed. I just need to isolate c. How can I remove the power of 2? By simply squaring both sides, or by multiplying the exponent by 2. So I'll end up having 1 over c is equal to 1 over 4. If I cross multiply, then the value of c will just be equal to 4. And hence f of x is just equal to negative log x base 4. Negative log x base 4. So I know that c is equal to 4 and d is equal to 2. Now they want us to determine the equation of the inverse of g of x in the form of y. How can I find an inverse, guys? I know that for me to find an inverse, I just need to reflect the original graph on the line y is equal to x. Are you together? Just reflect this on the line which is y is equal to x, and then that simply means whenever I come across y, I'll substitute x, and whenever I come across x, I'll substitute y. The only thing I need to do now is to simply isolate the value of y. I can divide both sides by 2. I'll end up having x over 2 being equal to y squared. If I take the square root on both sides, y will simply be plus or minus the square root of x all over 2. But since, guys, the domain of our original graph was restricted, that means the range of this of the inverse is supposed to be restricted as well, so that it will be a function. So y is just equal to positive square root of x all over 2. Y is just the square root of x over 2. Né? Okay, and then now they want us to find the inverse, rather, what's in the equation of the inverse of h in the form of y if h is the reflection of f in the x-axis. Okay, firstly they are reflecting f of x on the x-axis for us to find h of x. Né? So h of x, guys, will simply be equal to negative f of x, because whenever you reflect your graph on the x-axis, you are basically changing the sign of y. So h of x is just equal to negative minus the log of x base 4, and hence h of x is equal to the log of x base 4. But I was never asked to find the equation of h. I was asked to find the equation of the inverse of h. How can I find the inverse of h? By simply reflecting the graph of h of x on the line which is y is equal to x, and then I'll just interchange both x and y. I'll have x on the left hand side and then y over there, and then all I need to do, guys, is to simply isolate the value of y. How can I do that? By making 4 the base on the other side. So I'll have 4 to the power x is equal to y. So the inverse of h of x, y is basically equal to 4 to the power x. And then now I'm supposed to determine the values of x for which the inverse of h of x is greater than 0. The values of x for which the inverse of h of x is greater than 0. If you draw the graph of the inverse of h, it will simply be a graph like this. It will pass through a point of intercept whereby y is 1 and x is 0. Are you together? So we can see that, guys, our graph is always above the x-axis. So the inverse of h of x is always above the x-axis for x element of real numbers. Are you together? The domain of our exponential graph, not the domain rather, but our graph is above the x-axis for all values of x. That's how, guys, we're supposed to tackle this question over there. So please do stay tuned and wait for more videos. Thank you.